In your notes packet, locate your notes solving absolute value equations. Recall that the definition of absolute value of a quantity is the distance from zero on the number line. So if we want to find the solutions to the absolute value of x equals 7, we're looking for the numbers that are 7 units from the origin on the number line. So let's draw a number line. So which numbers are 7 units from the origin? The origin is 0. Well, we say positive 7 is 7 units away, but there's also negative 7. So that's why the absolute value gives us a positive value and a negative value. Alright, we're going to follow these steps when we solve an absolute value equation. Step number 1, we're going to isolate the absolute value. Step number 2, we're going to write two equations. It's like a piecewise, remember? So the positive one and the negative one. Then we're going to solve each equation, and we're going to remember to check our answers, make sure they work, and looking for extraneous solutions. And then finally, we're going to graph the solutions. A solid dot will represent each solution. So look at example number 1. The absolute value of x plus 3 equals 8. So the first thing we need to do is isolate the absolute value. So we're going to subtract 3 from both sides. So the absolute value of x is equal to 8 minus 3, which is 5. Now we're going to break it into two equations. So we got x equals 5 or x equals negative 5. Well, x is already isolated, so now we just check our answers and then graph our solutions. Alright, always go back to the original equation when you plug in to check your solutions. So the absolute value of negative 5 plus 3 is equal to 8. Well, the absolute value of negative 5 is 5. 5 plus 3 equals 8. That's true, so let's graph negative 5. It makes our equation true. Alright, check the positive 5. The absolute value of 5 plus 3 equals 8. Well, the absolute value of 5 is 5 plus 3, and that equals 8. Also true, so there's my second solution. Alright, so the set negative 5, 5 are the solutions, or the zeros, of this absolute value equation. Alright, look at number 2. Absolute value of x is equal to negative 3. Watch out when you have negatives and absolute values, because remember the absolute value is always going to give me a positive value. So there's no way a positive number is going to equal to negative 3. So here's an example we have no solution, or the empty set. There's no value we can plug in for x that will give us negative 3 in this case. So watch out for absolute values and negatives. Alright, example 3. Alright, isolate, step 1. So that means we need to, before we break it into two equations, we need to divide both sides by 3. So if I divide both sides by 3, I get the absolute value of 5x minus 10. 45 divided by 3 is 15. Alright, step 2. Break it into two equations. Once you get the absolute value, isolate it. So I've got 5x minus 10 equals 15. Or 5x minus 10 equals negative 15. Step 3, solve for x. So I'm going to add 10. So negative 15 plus 10 is negative 5. Divide by 5 and get negative 1. And I'll check before I graph. Solve the second equation. Add 10. 5x equals 25. Divide by 5. So 25 divided by 5 is 5. Alright, let's check both. Now make sure you go back to the original equation, this one, to check your answers. So let's put in negative 1 first. Absolute value, so 3 times the absolute value, 5 times negative 1 is negative 5 minus 10, and I want that to equal 45. So negative 5 minus 10 is negative 15. Absolute value of negative 15 is positive 15. Well, 3 times 15 is 45. That's a true statement. So I'm going to graph negative 1. All right, let's check 5. Go back to the original. So 3 times the absolute value of 5 times 5 is 25, minus 10 equals 45. 3 times absolute value, 25 minus 10 is 15. Absolute value of 15 is 15, so 3 times 15, that equals 45. So that one also checks. So let's graph 5. So my two solutions are -1 or 5. All right, step number 4. All right, step 1. Absolute value is already by itself, so I can go ahead and break into two equations. So I'm going to have 2x plus 12 equals to 4x, or 2x plus 12 equals to negative 4x. All right, let's solve. All right, when I go to solve this, I've got x's on both sides. So I can either move my x's to the left, numbers to the right, or vice versa. All right. Just to be consistent, I'm going to move my x's to the left each time, and my non-x's to the right. So I'm going to add 4 to 2x. So I get 2x plus 4x is 6x plus 12 equals to 0. Subtract 12 and divide by 6 and get -2. All right, don't graph it until you check it. All right, second thing, I'm going to subtract 4. So 2x minus 4x, -2x plus 12 equals to 0. Subtract 12 and get -12. Divide by -2 and get 6. All right, here's where it's super important to recheck. When you check your answers, check them in the original equation. So let's check that -2. The absolute value of 2 times -2 is -4, plus 12 is equal to 4 times -2 is -8. All right, so continue to simplify. -4 plus 12 is +8. The absolute value of 8 is 8. Well, 8 doesn't equal to -8. So that's what I mean by an extraneous solution. When you go back to plug it into the original equation, it doesn't make the original equation true. So that means it's not a solution to our equation. It's extraneous. It looks like we did everything correctly, but it doesn't work in the original. All right, let's check 6. Absolute value of 2 times 6 is 12, plus 12 is equal to 4 times 6 is 24. All right, 12 plus 12 is 24. The absolute value of 24 is 24. So this one checks. So our only solution here is 6. So that's why we're only going to graph 1, 6. So what was special about this equation? How was this equation different than the others? Well, you may say, notice that there are variables on both sides, or x's on both sides. That's a dead giveaway that there might be a possible extraneous solution. So make sure you check. All right, look at the following. All right, I see variables on both sides, so I'm probably going to look out for extraneous. The absolute value is already isolated, so let's break it into two equations. So I have 2x minus 4 equals 4x minus 1. Or, all right, be super careful here. We got 2x minus 4 is equal to the opposite of that entire quantity, 4x minus 1. That's where people make a mistake. You got to distribute that negative. All right, let's solve both equations. So we got 2x minus 4. Distribute the negative, so we get -4x plus 1. All right, solve for x. I'm going to go left with my x's, so I'm going to add 4x to 2x and get 6x. Add 4. 4 plus 1 is 5, so x is equal to 5, 6. All right, let's solve the second one. This time I'm going to subtract 4x. 2x minus 4x is -2x. Minus 4 minus 1 equals -1. Add 4 this time. And I'm going to add 4 and get 4 minus 1 is 3. Divide by negative 2. So 3 divided by negative 2 is negative 3/2. All right, let's check both of these. All right, got fractions, so you might want to grab your calculator to plug them in to check. All right, so let's plug it into the original equation. I'm going to do 5/6 first. All right, so 2 times 5/6 is 10/6 minus 4 is equal to 4 times 5/6 is 26 minus 1. All right, got some fractions simplify here. Simplify by 2, I get 5/3 minus 4. Let's also simplify that fraction too while we're at it. So that's 10/3 minus 1. All right, 5/3 minus 4 is negative 7/3. 10/3 minus 1 is 7/3. The absolute value of negative 7/3 is 7/3. All right, so that one works. That one's good. We can graph 5/6. All right, let's check negative 2/3. Give myself some room here to work. Okay, negative 2/3. Back into the original, remember. All right, 2 times negative 2/3 is negative 3 minus 4 is equal to 4 times 2/3 is negative 6 minus 1. All right, so we get the absolute value of negative 7 is equal to negative 7. But remember, the absolute value of negative 7 is actually 7, which does not equal to negative 7. So that's going to make my negative 2/3 extraneous. So the only solution here is 5/6. All right, but please don't assume that just because it's a negative answer when you solve your equation that's going to be extraneous. Always remember to check in the original equation. All right, so there's our summary of what we did. If you have any questions, like always, ask in class.